All right, this is a quick setup on the production of carbon dioxide. Okay, let me see if I can take a picture of the board really quickly. And the board says that, all right? So you can refer back to that, and I'm going to talk about that equation on the board. You see where it says HCl plus NaHCO3, and then on the other side of the drawing it says H2O plus CO2 plus NaCl. The Na on the left is combined with the bicarbonate ion, which has a -1 charge. And that bicarbonate ion attaches to the hydrogen in a double replacement reaction and produces carbonic acid, which decomposes right away spontaneously into water and carbon dioxide. You see that? Okay. All right, let me put this back. And we'll go like this, and we're back. All right, now. Okay. So what I want to show you is the nature of a gas. Okay, just a little bit. Okay. This is not everything you want to know about a gas, but this is sodium bicarbonate. Okay, is an Erlenmeyer flask. Okay. Being a little sloppy. Okay. People use this, so I'm not terribly concerned, but never do this. Wear goggles and things like that. But the reason I'm not treating this as some dangerous experiment, which I really wouldn't do anyway, in here in front of a camera especially, is that sodium bicarbonate is oftentimes used in what? Baking, yeah? So it's not a terribly dangerous chemical. And this is extremely dilute hydrochloric acid. Doesn't the word hydrochloric acid, doesn't it sound horrid? Yeah, doesn't it? Yeah. Well, your stomach, and this won't really mean anything to you, your stomach is something called 1 molar. That's the concentration, and we're going to learn that in 2 chapters from now. Is 1 molar, essentially, your stomach is 1 molar hydrochloric acid. There's an enzyme in your stomach that helps to digest protein. The stomach is where protein is digested, more or less. And it's something called pepsin. Anybody ever hear of the word pepsin? Yeah. Well, in order for pepsin to work, it needs an acid. It needs hydrochloric acid. It needs the H ion. It needs an acid. Specifically hydrochloric acid. So your stomach produces 1 molar hydrochloric acid. This is 1/10 the acid in your stomach. So is it terribly dangerous? No, not even a little bit. Okay. So what I'm going to do is I'm going to produce some carbon dioxide, okay? So let me do that. So I'm going to do the reaction that's on the board. Sodium bicarbonate. I have black here so you can maybe see the trace of carbon dioxide. Okay, not terribly reactive, but gas is coming off. You may not be able to see it very well. Okay, but it's in there. Now, carbon dioxide is very heavy. Think about it this way. Air is about 80% nitrogen, yes, which is 28. 2 times 14, nitrogen, right? The molar mass of nitrogen is 28, nitrogen gas. The molar mass of oxygen is 32. It's about 80% this, 20% this, some other things thrown in, right? So the average weight is about 29, right? The average weight is 29-ish, yes? Carbon dioxide is 44. So carbon dioxide is very heavy. Does carbon dioxide support combustion? Yes or no? Does it burn? Carbon dioxide burns. So in other words, the carbon dioxide that they use in fire extinguishers is not a good thing to use? Yes or no? Does carbon dioxide burn? No. So there should be carbon dioxide in here, right? I should be able to pour this because it's a fluid, right? There's not much left. All right, so much for that experiment. But what I'll do is I'm going to do it again. I'm just going to get a little bit more powerful acid, a little bit more powerful, not much, maybe twice, and I'll run it again. So this is part 1, and then you go to part 2. Clear? So everything is set up. Yes, I'll come back and I'll try it again. No experiment is a failure. Well, they are, I guess, but you'll learn from them, okay? So it's okay. All right? Be right back. Okay, well, this is going to be trial 2. I'm going to splice this together, so if you're seeing this right back to back, you'll know why. It seems a little weird. Okay, what I'm going to use is same stuff. I have goggles on this time. Okay, see my goggles. Okay, I'm using 6 molar HCl. Not something you want to get in your eyes. It's about 6 times more powerful than stuff in your stomach. You know what it feels like when you get acid indigestion? Well, I don't want acid indigestion on my face. The front row here has goggles, right? So I'm going to do the reaction. You okay with that? You ready? A bit more vigorous. You see that? Now you can see the carbon dioxide coming out of the top. Did you see that? Did you see it? It may have gotten it on tape. Okay, now, I know I have plenty of carbon dioxide. I'm confident. So, a gas is a fluid because it flows, correct?
Yeah.
Let's test that hypothesis. Okay? You ready? Isn't that cool? Is that cool or what? Shall we do it again?
Yeah.
All right. You ready? Carbon dioxide flows, right? Cool or what? Right? Yes or no?
Yes.
Once more.
Yeah.
Let's go completely crazy. We're going to take a little piece of paper, not big. Okay, not big. I'm going to put it in my hands. Oh, I don't have any left. None left. Oh, there it goes. Okay. Never be afraid to blow out the fire. That's always important. Okay. So shall we do it again? Once more. Okay. All right. Here's some acid. All right. An experiment's great. I love it when they don't work. As long as nobody gets hurt, of course. There's plenty of sodium bicarbonate in here. Let's do this, and let's put something on the top. I have the lid somewhere. Here it is. We'll put the lid on, just to keep the gas in there. Lot, huh? Vigorous or what? You see it? You see it coming out? Hopefully you're able to see that on film. All right, now, we'll do this. Again, we'll try the piece of paper trick. Notice I'm not using a large piece of paper because I'm so used to experiments not working. If you think I know a lot about chemistry, the amount I know about chemistry is directly proportional to the number of failed experiments I've done. The more failure you have in chemistry, the more you learn it. Isn't that weird? Very cold, too. Cool or what? I need a round of applause, please. Okay. All right, now, let me break the experiment down and we'll come back, okay? Be 2 minutes. Yes? All right. Oh, the camera wasn't on. Oh, just kidding.